Okay, so somehow I hit the stop on my video. So that is why this video had to get split into two. Very end of the last video, we were talking about how permutations and combinations use up. They don't allow repeats. A lot of students start thinking that all counting must be either a permutation or a combination. Think about passwords. I think we had done one. It was an 8-digit or 8-character password. We had said you could only have a letter here, and this was letter or number. So we said 26 and then 36, 36, whatever, right? So obviously this is not a combination nor a permutation. It is simply put your dashes and think through if there's any restriction or there's no restrictions. So if a problem is going to allow repeats by its very nature, then it cannot be a permutation or a combination, because permutations and combinations, even though they're very different, both of them do not allow repeats. I also wanted to do a quick problem. It's not my favorite, but it's in so many different books. It's about ice cream. I think they think it's cute for the kids, right? Ice cream cones versus milkshakes. So let's say we have 3 flavors and we're getting 2 scoops. That's a lot of ice cream, but we're going to go with that. And again, I think they're just trying to make it cute, because think about it. If you have a cone in your hand, you can tell which scoop of ice cream they put on the bottom and then which scoop of ice cream they put on top, right? So a cone is just a cute way to get kids to understand it's a permutation because order matters. So 3 times 2, there are 6 ways. This is 3 permutation 2. Obviously, this is not allowing for if you want 2 scoops of the same, right? If you want 2 scoops, or if you're going to allow someone to get chocolate chocolate or vanilla vanilla or strawberry strawberry or something, then it is no longer a permutation. It's just the dash method. Yeah, 3 times 3. There would be 9 ways. So this is why I have an issue. They think it's a really cute way to get the kids to understand order matters and that it's a permutation, but we all know, and many of us will get the same 2 scoops on an ice cream cone, right? So that can confuse kids because they're probably thinking, yeah, there's 9 ways. But as long as you write a word problem where it's very clear on whether you're allowing repeats, then I guess it's not a problem. The first time I read the problem about a milkshake, I didn't get it. And then I probably had to ask someone. But yeah, think about it. If they put the scoops into a blender, you're never going to know which scoop they put in first, right? So milkshake technically is to try to help the kids to understand that it's a combination. You just get to pick 2 flavors out of the 3. The repeats get even more confusing, so I'm not even going to go that far. Because again, this is not my favorite problem. But I see it in so many different textbooks. I feel like it would do you a disservice not to mention that these are supposed to be cute and easy for the kids. I actually think that it makes things way too complicated. Next, I'm going to do a problem that I seem to always be asked about in office hours. It's from worksheet 1. You don't have to get it out. I can probably put up what we need. Where am I? Okay, worksheet 1, number 20. Where am I? It tells you the probability of event E is 29%. The probability of event F is 43%. and they ask different questions. Now, I'm going to, just so I don't have to write it over and over. This entire problem is making sure you know the addition rule. That E or F equals E plus F minus E and F. So we're going to keep this tucked over here because that's what this problem's about. So part A says if E and F equals 0.15, then what does E or F equal? So yeah, they just want us to do the addition rule. E plus F minus E and F. They're just getting you to apply. I don't feel like, let me look at my answer key. I don't feel like looking that up. 0.57. Okay. They're also getting you to practice vocabulary words. Part B says E and F are mutually exclusive. What is E or F? Sorry. Mutually exclusive is trying to tell you that E and F cannot happen at the same time. It is 0. That is somewhere in your lecture notes. So I know that E union F is 0.29 plus 0.43 minus 0 since it's mutually exclusive. All right, well, I feel like I'm going to run out of room. Let me erase. Part C is getting you to practice another concept, vocabulary word. It says E and F are independent. So it wants to know what E or F, E union F is. Well, it's E plus F minus. Remember, if it's independent, that's the multiplication rule. It tells you that E and F is E times F. So that's where they were going with this part. So I'm just going to multiply the two. That's because the only reason we get to do that is because it said independent. That will give you 0.5953. Oh, part D is the easiest. It just says, what is E prime? That was the complement, so that's 1 minus E. 1 minus 0.29 is 0.71. Getting you to practice the addition rule. Let me show you part of a problem I had put on a test in the past. It did not go well. I'm only showing you part of it, but okay, so I've given you A, I've given you B, I've given you the union, the or, and I'm asking you for the and. So A or B equals A plus B minus A and B. So we've got a few things going on here. We've got you practicing the addition rule. We have you dealing with terrible numbers, decimals and fractions that do not have the same bottom. And then we have algebra. Now, I know I allow calculators. These numbers get really yucky, and I do want you to practice fractions. You know, this whole thing is begging to go into 18ths. Because 1/2, hopefully you know, is 9/18. 1/3, well, I just got to multiply top and bottom by 6, right? 6/18 minus, I'm just going to call that x right now so I don't have to keep writing it because that's my unknown. So we have 13/18 equals 15/18 minus x. You know algebra. There's lots of next steps. It doesn't really matter as long as you get to the right answer. minus 15/18 from both sides. So I have minus 2/18 equals minus x, or x equals 2/18, which is the A and B part. So yeah, 15 minus 2 is 13, yes. I'm sitting here thinking, I had one more problem, but honestly, I think it's going to do more harm than good. I think it's going to confuse things and we're not going to get much out of it, so I think I will skip that. So now we're going to say this is the end to the video. I don't plan on making more videos unless students need to see me do a lot more with probability outside of office hours. So this was the second part of video number 7. Bye.